Hello everyone, let us continue from where we have stopped. If you are watching this video, make sure that you also watch part 1 and part 2 video lectures on most frequently asked Viva questions. Let us move on to the next question. What is data redundancy and what are the problems associated with data redundancy? So data redundancy means duplication of data at multiple places in the database. Okay, duplication means repetition. Okay, if you are trying to repeat the same data at multiple places in the database, then it will lead to data redundancy. And if at all data redundancy is there in your database, then what are the problems you are likely to face? The problems that will arise due to this data redundancy are insertion problems, updation problems, and deletion problems. So, what do you mean by anomaly? Anomaly means problems. Okay, anomaly means problem. So, data redundancy will lead to insertion problem or insertion anomaly, updation anomaly, and also deletion anomaly. So, these are the problems that will arise due to data redundancy. So, what is the solution to this data redundancy? Okay, the solution to this data redundancy problem is normalization. So what is normalization? This is the definition of normalization. Normalization is the process of decomposing a relation. A relation is also called as a table, right? So normalization is the process of decomposing a relation into smaller relations or smaller tables, so as to minimize insertion, updation, and deletion anomalies which are caused due to data redundancy. So, in simple terms, if someone asks you to tell what is normalization, in normalization, what are you doing? You are decomposing or splitting a relation into smaller relations. Thereby, you are minimizing this insertion, updation, and deletion problems. Next, what are the various normal forms? So, normalization is typically achieved with the help of these normal forms. So, you have various normal forms like first normal form, second normal form, third normal form, Boyce Codd normal form, and fourth normal form. And these are the short names. 1NF stands for first normal form, 2NF stands for second normal form, 3NF for third normal form, BCNF for Boyce Codd normal form, and 4NF for fourth normal form. It all begins with unnormalized relation. Okay, it all begins with unnormalized relation or a relation which is unnormalized. From unnormalized relation, we will move on to first normal form. From first normal form, we'll convert it into second normal form. From second normal form, we'll convert the relation into third normal form. From third normal form, the relation will be converted into Boyce Codd normal form and the fourth normal form. So what do you mean by relation? Relation means a table. So the table will be converted into first normal form, and then from first to second, second to third, third to BCNF, and BCNF to fourth normal forms. Next question is, how do you define first normal form or 1NF? A relation or a table is in 1NF if it contains only atomic values. So focus on this terminology, atomic. Atomic means single values. Atomic means single values. Or this is the other definition. A relation or table is in 1NF if every attribute or column in that relation contains only atomic values. So how do you explain this? Now you consider this table. In this table, you can see that in this particular cell, okay, in this particular cell, you are having Java and Python. Two values are there, okay, in a single cell. In a single cell, the table is consisting of three columns: student ID, student name, and course. And in this course column, in this particular cell, you are having two values or multiple values, Java and Python, and this is not allowed in 1NF, and hence this table is not in first normal form. So how do you convert this first normal form into how do you convert this unnormalized relation into first normal form? And this is how you convert this unnormalized relation into first normal form. What are you doing here? This Java and Python, you are taking it on separate cells. You're taking them on separate cells, on separate records, on separate records. Now you can see here Java is in a placed in a separate record and Python is placed in a separate record, and the remaining two values, student ID and student name, okay, they are copied as it is. They are copied as it is. Now you can see in this table there is no cell which is having more than one value. There is no cell which is having more than one value. That means all the values are atomic. All the values are atomic. Okay, if this is the case, a table in which you are not having any multiple values in the cells and all the values are atomic, then the table is said to be in 1NF. 1NF. This is an unnormalized relation. From unnormalized relation, we are converting it into first normal form. First normal form. Next, define 2NF or second normal form. A relation is said to be in second normal form if it is in first normal form. This is the first condition. First condition is a relation is said to be in second normal form. In order to be, for a relation to be in second normal form, it has to be in first normal form. This is the first condition. And the relation does not contain any partial dependencies. So what do you mean by partial dependencies? Partial dependencies means all non-key attributes, should be fully functionally dependent on the primary key. All non-key attributes should be fully functionally dependent on the primary key. So what is a key attribute and what is a non-key attribute? A key attribute is an attribute which is part of the primary key. Okay, a key attribute is an attribute which is part of the primary key, and an attribute which is not part of the primary key is called as non-key attributes. Okay, so partial dependency should not be there in the table. That is what this second normal form is telling. So if you are looking at this example, looking at this table, you are having three columns: faculty ID, subject, and age of the faculty. Now what is the primary key or candidate key in this table? Okay, now there is no particular, okay, column or field in this table which can act as a primary key. So you are taking help of two columns, faculty ID and subject, and these two columns are collectively acting as the primary key or the candidate key. Okay, so faculty and subject, these two are collectively acting as the primary key or the candidate key, right? Now if at all, if you want to get the age of the faculty, okay, in order to get the age of the faculty, then I don't need these two columns. I can get age directly from faculty ID. I can get the age of the faculty directly from faculty ID. I don't need to take help of this subject. Okay, so thereby, okay, partial dependency is existing. What is partial dependency telling? Partial dependency is telling that non-key attribute, in this case age is a non-key attribute. Okay, now age is a non-key attribute, and what are the candidate keys are the key attributes? Faculty ID and subject are the key attributes. Okay, so if at all, if I want to get age, I can get it directly from faculty ID. I don't need to take help of subject. Okay, and hence partial dependency is existing, right? So how do I remove this partial dependency? Okay, I can remove this partial dependency by splitting this relation or table into two smaller tables again. Okay, one with faculty ID and age column, and the other table with faculty ID and subject columns. Thereby you are removing this partial dependency. Now if at all, if there is no partial dependency, then the table is said to be in second normal form. Next question, define 3NF or third normal form. A relation is said to be in 3NF or third normal form if it is in 2NF and there is no transitive dependencies among non-key attributes. Okay, so in order for a table to be in 3NF, the first condition is table should be in 2NF. Okay, in order for the table to be in 2NF, it should be in 1NF, right? So a relation is said to be in 3NF if it is in 2NF, and one more condition is there should be no transitive dependencies among non-key attributes. Transitive dependencies should not be there. The other definition is no non-prime attribute is transitively dependent on the primary key attribute. For any non-trivial functional dependency x to a, then either x is a super key or a is a prime attribute. Okay, so what is a prime attribute and what is a non-prime attribute? Prime attribute is that attribute which is part of the key. Okay, and non-prime attribute are those attributes which are not part of the keys. Okay, So let us see this with the help of an example. There's a table called as employee department, details table, employee details table, and these are the columns: employee ID, employee name, city, state, and zip. And what are the super keys in this? Super keys in this are employee ID. The primary key is employee ID. And what are the other keys that can be generated from this table? Employee ID and name combination I can take, employee ID and city combination I can take, employee ID and state combination I can take. So this entire set, okay, of keys are called as super keys. This entire set of keys are called as super keys. Now, if you are taking this example, if you are taking city and state, okay, in this example, city and state are dependent on zip. This column city and the column state, okay, they are dependent on zip, okay, zip code, right? And zip is dependent on employee ID, and zip is dependent on employee ID, EID, okay, and hence transitive dependency is existing, and hence transitive dependency is existing, and hence the table is not in 3NF, and hence the table is not in 3NF. 3NF is telling there should be no transitive dependencies, right? So what is the solution to this problem? The solution to this problem is we are splitting this table into two tables. Okay, one is called as employee EMP table and the other is called as EMP zip table, right? So this is the solution. Thereby we are removing these transitive dependencies. And if the table is not having transitive dependencies, then the table is said to be in 3NF. Define Boy's chord normal form or BCNF. This is the definition. For any non-trivial functional dependency x to a, x must be the super key. X must be the